This is our second project in grade 12 computer hardware, and our first step in building the CHUMP 4-bit computer. For this submission, we were instructed to build the clock and program counter aspects of CHUMP and write our own program that we hope to run a month from now. Also, to advance further in the project, I wired up the EEPROM chip to display my written program on a set of 8 LEDs. There are two modes to the clock, astable and monostable. A series of combinational logic gates are used to switch between the astable and monostable modes. This clock signal is then fed to the program counter. This is a device that takes a clock signal and counts up in binary to a maximum value of 16. The program counter also has the ability to skip to a certain value controlled by these two switches, which in the future will be the C and Z lines. The program counter also has a clear function, which resets the count to 0, controlled by this button.
So this is my code that we created in Japanese. Let's run through it. So the first line here is read x. So we're going to take the value of x and put it onto the address register, which puts it into RAM. Then we're going to load it, which puts it into the accumulator here. And then we're going to subtract 3 from the accumulator, which is just the value of x, and it's going to put that value, that subtracted value, back into the accumulator. Then we're going to say if 0, 9, which is basically saying if this value in the accumulator is 0, go to address 9. Let's say it's not equal to 0, so we're just going to go to the next address. The next address, we're going to read x again. So let's put it into RAM. Then we're going to load it into the accumulator. And then we're going to add 1. So it's just adding 1 to whatever is in the accumulator, which in this case is x. And then we're going to store it to x. So store to x in RAM. Then we're going to go back to 1. Go back to here and then go through the program again. So let's say we go through the program again. We go through these 3 things. And let's say if 0 is equal to this, the accumulator value is equal to 0. Then we're going to go to address 9, which is this one right here. So that's going to read x, put it into the RAM, load it into the accumulator, and then we're going to read y. So we're going to read y, put it into the RAM, and then we're going to subtract it, which is just saying subtract y. So we're going to take y, put it into the ALU, and then we're going to take the accumulator value, put it into this A operand, subtract the A operand, subtract the B operand from the A operand, and then put that value in the accumulator. Then we're going to store that value to y, which is address 7, and then we're going to go to 15, which is just the last line in the code, and it's just going to stay there forever.